A system has two charges, QA, QB, and is located at 2 points respectively. And the question is very straightforward. What are the total charge and the electric dipole moment of the system? So, as the diagram you can see here, both of them, whatever be the axis, right? The diagram that you draw, because this question was provided without a diagram, right? The diagram that you draw literally has to be according to the convention that they are given. So your coordinates must be the z-axis, so that's why x and y given here, and the z-axis on the third axis as well. So it's a three-dimensional axis. However, the calculations that you need to do, well, they are all coming in the one-dimensional plane only. No need for changing coordinates, no need for worrying, because ultimately, even though it's a z-axis question, it is still, ultimately the question is still a one-dimensional problem. So all you have to do is to evaluate for the only one dimension that you have here, the one dimension that you need to consider, which is of course the dipole moment. The total charge, well, you just add the system up. So the total charge, well, when you add it up, QA plus QB is equal to capital Q, you're going to get a total value, a huge value of, in fact, 0 coulomb, because in fact both of them are equal and opposite charges. So it's just like Q minus Q is equal to Q, which is equal to 0. 0 coulomb is the total charge of the system. And conversely, now we are going to calculate the dipole moment. The dipole moment is equal to one charge. Okay, dipole moment, remember the formula. The electric dipole moment is equal to one charge into the distance between them, which is in fact 30 centimeter. Remember, the distance here also has to be converted into SI units. So the electrical dipole moment is equal to Q into the distance between them. So the unit of electric dipole moment, let's not forget that unit, which is P. So ultimately, when you multiply both of them, 2.5 into 10 to the power minus 7 multiplied by 10 to the power minus 2 into 15, because I have to convert 15 plus 15, because the distance is between both of them. So remember, the distance AB is the distance that I have to calculate here. So that will give me my final answer, which after multiplication I will get it as 7.5 into 10 to the power minus 8. And the direction is very simple. Since the direction is positive, it is along the positive z-axis. So the dipole moment is along the positive x-axis. Remember, electric dipole moment is a vector. Thank you, students.